Hello everyone and welcome to the CEC and ME guys. We have discussed the deflection formula. Now in this video we will discuss the how to calculate a reaction forces on a beam, simply supported beam, hinge and cantilever beam using the trick. So here I am going to discuss the trick to find reaction forces. So let's start with the example. So first of all, take the example. Here is the beam, simply supported beam of this span 4L is given. Here the three concentrated point load are acting, W upward, 3W downward, and here 2W upward, and the length between this all of this is the L. It is given that. So now calculate the reaction forces at the point A and at the point B. So to find the reaction force at the point A and the B, first of all we are required to consider the 2 to 3 things in mind. First, check for the vertical forces is 0 or not, and moment, summation of moment is equals to 0 or not. If both of these conditions are the satisfied, then we can say that the vertical reaction is equals to 0. This is the case number first. And case number second, if the summation of vertical forces is 0 but the summation of moment is not equals to 0, then in this case vertical reaction is not equals to 0, and they will be equal and opposite, in the direction. So keep it in mind. So by this two cases we will find the reaction forces at both the end. So let's start. Here I am again sketching the question which is given. The beam, simply supported beam of the length and a 4L is given, and here the point load is acting the W, here the 3W, here 2W, and the distance between all of them is equals to kitni hai? L. So find the reaction at the point A and the point B. First of check the vertical reaction. So vertical reaction, W upward, 2W upward, that means W and 2W, 3W, that is equals to क्या हो जाएगा अपना 3W minus 3W, that is equals to 0. Now check for the movement. So when you will check the movement about A is equals to, here moment W into L. Here I am taking the anti-clockwise is positive and clockwise is the negative, minus 3W and length between the point A and this 2L, so 3W into 2L, then again the anti-clockwise, so take 2W multiply by the 3L. So from here we can see that the WL minus 6WL plus 6WL. So it will be equals to WL. So the moment will not equals to 0. So we can apply this method. So what will we do? We are considering first we are considering the point A and finding the reaction at the A point. So reaction at the point A is equals to, first take the force is away, that means we have to be take as the, here we are taking the direction as the upward. Okay, here I am taking the upward direction. So if the force in the same direction as we assume, so take the negative sign, multiply by the distance from the other end. So what will it? 3L plus 3W is opposite to the direction what we has assumed. So it will be 3W into the remaining distance from the other point is 2L minus, because it is in the same direction, so minus 2W into the remaining distance is the L divided by the length of a spin, which is equals to the L plus L, that is equals to 4L. So when you will calculate this will be the 3WL plus 6WL minus 2WL by 4L. So it will give result of the 3, 6 and minus 2. 3 and 2, 5. So it will be the WL by 4. It will give the result WL by 4. So not L, because from L to L cancels. So W by 4 reaction at the point A. And as we have discussed in the case that when the vertical forces are 0 but the moment is not equals to 0, that means the reaction forces are opposite in direction. So that point B, the reaction will be in the downward direction and in the magnitude W by 4. So from this you can calculate the any of the reaction, whatever you find. Now take the example of the one of the other type of the question like the moment. So here I am taking the example of a simply supported beam consisting of the three moment M, 1M here and 1M here, and name it point A, B, C, D and E, and the length between this all of the point are given as the L by 4, L by 4, L by 4 and L by 4, and total length is the L. Okay. So you are required to find out the reaction forces at both the end, at the point A and the point B. So the same concept will here when the vertical force is equals to 0 but the moment is not equals to 0, then the vertical reaction are equal and opposite in direction. And the reaction forces is given by the net moment divided by the span. So first of all we are taking the moment at the point reaction, we are finding the reaction at the A. So let's merge all this moment to the single moment. So what will it? The one at the point B anti-clockwise, point C anti-clockwise and point D clockwise. So the ultimately moment at the point C we can assume W moment M as the anti-clockwise direction. Got it? Equivalent moment we can say that the summation of moment is equals to at the point B m plus at the point C m minus at point D m. So ultimately the moment will be the m. So equivalent moment we are representing here. Now do one thing for the reaction at the point A. When the moment is in the anti-clockwise direction, so it will opposes in the upward direction. So here the reaction at the point A will be in the upward direction and the at point B in the downward direction. So from the diagram we will give the direction directly. Now we are going to find the value of this reaction at the point A and B. So what we are required to do, reaction at A is given by the moment divided by length of spin. That's it. So this reaction force will equals to the m by L and this will be equals to the m by L. So we have discussed the two of the cases when a simply supported beam consisting of the concentrated point load or moment. So how to calculate reaction? So it's all about to find the reaction forces with the trick. So in the next video we will meet with the next topic. For more video, subscribe our channel. Thank you.